Okay, in this set of problems, we're going to establish for problems A and B the U1, U2, and U3 values. And then from that, based on the graspable math activity that was just completed, we're going to establish the long-run value. So if you go ahead and do problem A, turn the video off, complete problem A, and then turn the video back on to check your answers, or if you need additional assistance on problem A, then use the video as a teaching tool. All right, so for U0, we're told the answer is 48. So for U of 1, we're going to take 0.75, multiply it by 48, add 25 to it. And then that answer will be U of 1. So 3/4 of 48 plus 25 is equal to 61. For U2, it's going to be 0.75 times our previous answer of 61 plus 25. So our answer here will be 70.75. And then U of 3 is 0.75 times our previous answer of 70.75 plus 25. And that answer is 78.0625. So again, to get to the next answer, we always take the previous answer and stick it back into our recursive formula to get to the next answer. Again, that's what it's a reminder, that's what the U of n minus 1 is telling us, is that U of n minus 1 means that we're taking the previous answer, and this U of n will get us to the next answer. So for the long run value, for A, is taught about in the graspable math activity. If I am trying to figure out where the set of answers is approaching, that it means that U of n and U of n minus 1 are going to get so close together that a calculator or even a spreadsheet, as I've demonstrated in class, the answer will get so close together that eventually the answers will become the same number, just because the computer can't distinguish the difference because of the rounding. But the answer of U n minus 1 and U of n will never be the same answer, but we're going to treat it as though it is, so we can figure out what is the U of n, what is 0.75 U of n minus 1 plus 25 as that gets bigger and bigger in this case. What number is it approaching? So like the graspable math activity, we're going to replace U of n and U of n minus 1 both with the letter C, which is the letter your textbook is using. And we're going to solve for C, and that will tell us where this sequence is approaching. So the first step in this, like in those opening problems, we're going to subtract 0.75 C from both sides. You get the C terms on the same side, so it's be like taking $1, taking away 75 cents. So we have 0.25 C equals 25. And then we have a multiplication problem. So we're going to divide both sides by 0.25. So C is approaching 100, or the limit, the long run value is approaching 100. So for this problem here, I'm going to graph this. We start at 48, and our graph is approaching 100. So I'm going to get the growth as U 1, 2, and 3 showed us. So we'll start at 48, and the graph is approaching, but we'll never get to 100. Go ahead and do problem B. And again, for problem B, A, and B only, we're doing the U1, U2, and U3. And then when you've completed problem B, you turn the video back on and check your work. And then move on to problem C and D. And again, all you're doing for C and D is find the long run value. And again, use the video as a way of checking your work. All right, so like problem A, starting with U of 0, which is 12. So U of 1 is going to be 0.9 times the U of 0 number plus 2. So 9/10 times 12 is 12.8. Oh, sorry, 10.8 plus 2. So the answer is 12.8. So we'll take that answer there, and we will move it to the next line. U of 2 is equal to 0.9 times 12.8 plus 2. That answer is 13.52. And the last one, U of 3, is equal to 0.9 times 13.52 plus 2. And that answer is 14.168. So again, take the previous answer, stick it in, back into our recursive formula to get to the next answer. So again, this is another example of growth. And so the second part of this is to determine the long run values. We take the recursive formula, the U of n and U of n minus 1 part. We replace the U of n minus 1 both with the letter C. First step is get the C terms on the same side of the equation, so we're going to subtract 0.9C from both sides. Take 0 on the right side, so it's a bit like reading up like a dollar, take away 90 cents, so it's 0.1C equals 2. Divide both sides by 0.1C, by 0.1. You get C by itself, or value of 1C. So C equals 20. So if we're going to look at the graph of this growth, we're starting at 12, we're going up to 20. We're starting at 12, and it's a growth. And the answers are approaching 20, but again, we'll never get to 20. All right, so problem C and D, if you've not completed these, go ahead and find the long run value for both of them. I've demonstrated a graph for the first two. If you also graph C and D once you have determined the long run value. Turn the video back on when you are ready to look at the work. All right, so for first step I'd probably do is I would subtract the 1 and the 2/10 to make 8/10. And for our problem D, I would subtract 1 and the 5/100 to actually get down to a single R value. This is basically like taking 100%, take away 20%, take away 20% to get us to our 80% for our value, which is 0.8 is the decimal number. This is like taking 100%, take away 5%, which gets us to 95%, which is the 0.95. So your textbook has two ways of kind of approaching R value. This is just basically saying we're starting at 100%, and these are both going to be decay since we're subtracting Alright, so first step here is to replace the u ven and u ven minus 1 both the letter C. And then we're going to subtract the 0.8 C from both sides. So that the C terms are on the same side of the equation. So on the right side, what's left is 0. And on the left side, we're left with basically like $1 take away 80 cents. We're left with 2/10 of the C. Divide both sides by 2/10. You value 1 C. So C is 0. So this decay, we are starting at a number of 62. And we're going down to the x-axis. So this would be a decay. Problem D, we're going to replace u ven minus 1 both with the letter C, and then solve for C. So we're going to subtract away 0.95 C from both sides. You get a 0 on the right side. So left side, like taking $1, take away 95 cents. So we're left with 5/100ths. C like a nickel. Equals 5. Divide both sides by the 5/100ths. Divide by 1 C, so C is equal to 100. So this problem here, starting at 45, and we're going up to 100. And that would be our log value. So one of the challenges with shifted geometric, which is the problem we're looking at here, problem D, as well as and as well as A and C, is sometimes it's really hard to know, is it a decay or is it a growth? For example, in problem D, we have a 0.95 that was started from both sides, so we end up with a, that's a decay, because we're multiplying by 95/100ths each time, but then we're adding 5 to that answer, which means that answer is going up. So, but the question is, in the combination of the two things, is the sequence itself going down as answers, or is it going up? So back at problem, the previous problem, like A and B, we had the answers were, I think problem B, the answer was going up, and here the answer is also going up. So it's always to your advantage when you're trying to graph a geometric sequence to at least find u of 1. To see if the answer went up or down from u of 0, because sometimes it will go down, sometimes it will go up. It's unlike the arithmetic that if you're adding, it's always going up, and if you're subtracting, it's always going down. Or for geometric, if you're multiplying by more than, if the number's bigger than 1, then that's a growth. If it's less, or between 0 and 1, then it's going to be a decay. But when you have this combination of a multiplication problem and addition, it's always best to check. Hopefully, you were able to get these problems done completely with high level of success. You may find going back and trying to do them again at a later time just to make sure you understand the process to be helpful.